Great.
Well, it's my pleasure to welcome Douglas Hornbeck.
Thank you. Thanks, Michael.
Excellent.
Stephanie Sunshine, the inventor of dStor, was scheduled to be here today, but she's ill, and so I'm going to do my best to give some information about this. So let's start. Let me share my screen. One moment. Thank you. I'm excited to be sharing information about dStor. I know there's a lot of excitement about it and about what we're building and we're about to launch. So thanks for this opportunity to talk about what we're so excited about and what occupies all our time. World runs on cloud computing and cloud storage. We all know this. Where corporations used to maintain their own computing equipment in data centers, today this function is becoming almost entirely outsourced to cloud computing companies. There's a joke about cloud computing, that is, there is no cloud, only someone else's computer. So whose computer is the world using to do their computing? Well, more than any other company, we have outsourced this to Amazon, like a lot of other things in our lives. Amazon Web Services is a giant of cloud computing. The runners-up are also among the most valuable companies in the world. Microsoft, Google, Alibaba, IBM, a half dozen companies control the vast majority of cloud computing in the world, and it is usually their most profitable line of business. This is the very picture of centralization, and it makes sense. Centralization is efficient. It lowers costs, but often it creates near monopolies that do not necessarily share those cost savings with their users. Blockchain opens up the world to efficient decentralization, and that's why I'd like to talk about now, a new way to organize an important part of cloud computing, cloud storage, that's decentralized instead of hyper-centralized. The blockchain future that many of us working on Telos and other chains dream of largely revolves around decentralized applications, dApps, that can be more efficient than their traditional competitors by not having a centralized company involved and instead being owned by their users. As I said before, centralization can be very efficient, but because that efficiency comes at the cost of high executive salaries, profits to investors, and other things, decentralized apps can actually be more efficient overall. Decentralization has other benefits as well, such as more egalitarian design and lack of single points of failure. Apps need storage, and decentralized apps need decentralized storage if they're going to be truly decentralized. But in fact, the options available in decentralized apps are either to use hyper-centralized cloud storage providers or to use slow IPFS systems that have problems with file permanence and slow delivery. So decentralized storage is needed by dApps, and yet it fails both of the purposes of cloud storage, both ensuring files don't actually disappear and delivering them quickly anywhere around the world. This lack of performant decentralized storage is actually one of the choke points that has limited the development of blockchain dApps for years. It's time for a better solution. My company, GoodBlock, has developed a new form of decentralized storage that solves the problems of prior attempts and opens up entirely new opportunities for dApps to be truly and fully decentralized. To understand the advantages of dStor, it'll help to understand the failings of the current decentralized storage offerings. Most of these are based on IPFS, or the Interplanetary File System. So far, it's actually just intraplanetary. IPFS is an open source project for storing and retrieving files from the internet. Now, since we remember that there's no cloud, there's only somebody else's computers, we should ask whose computers are running IPFS? And we should also ask another question too. Why are these people running them, right? We know why AWS is running its cloud storage service. It's the most profitable business it has. But who's running IPFS and why do they do it? What do they get out of it? Well, the fact is IPFS is generally run by enthusiasts because they support the idea ideologically. Also, maybe because they have an extra server sitting around somewhere that's not good for much else. Unlike AWS and Microsoft, they aren't running it to make money. And while that's admirable, it's also not very dependable. When people run something for free based on enthusiasm, they can just as easily turn it off when their enthusiasm wanes. They also tend to use old, slow equipment because it's free. Providing free services makes it hard to upgrade and expand. There's very little incentive to push the system to be faster and better. Doing so will cost the operators more money, but they don't get paid anything. This has always been understood to be a problem with IPFS. No one wants to entrust their business to a system that is built solely on utopian ideals. Several projects have tried to create incentives in the system using blockchain technology, but these proof-of-work systems have not delivered the desired results, and development is slow. This is part of the overall problem with IPFS as a business-ready platform for storage. There's really not the incentive to make it faster or better. On the technical side, IPFS falls down when it comes to how it seeds, caches, and presents data. What this means, in short, is that IPFS doesn't know when the files it stores or seeds are removed from the system. And as a result, files can disappear temporarily when the node storing them goes down, or permanently if that enthusiast running it just decides to do something else with their computer instead. There's no forward replication of files through the system to maintain a secure number of copies. Together, these structural and technical problems mean that IPFS is not secure enough about the persistence of data and does not deliver it quickly enough. Of course, there's blockchain-based attempts to deliver performant decentralized storage. Projects like Storage, Saya, Filecoin, and others attempt to use IPFS with proof-of-work blockchains to solve these problems, but to date, instead of providing business-ready solutions, they actually suffer from the problems of both IPFS and blockchain. So Good Block, we set out to solve these problems. Our vision of the decentralized future is that decentralized computing is a powerful force that will change computing and society as much as the introduction of the web. However, it's still awaiting a data storage layer that works technically and economically for all participants. In creating this, dStor will finally unlock the potential of blockchains to perform useful work and empower new forms of commerce, record keeping, and transparency that will revolutionize industries. So what's dStor? The dStor system provides a way for users and applications to store and rapidly access data globally at speeds rivaling centralized cloud storage, but at lower costs. The system consists of three groups: users, infrastructure providers, and dStor itself. A single person or entity can fall into more than one group. It could be a user and a provider. dStor users pay fees to store and allow the retrieval of data on the system. While anyone can be a user, the typical dStor user will be an organization or application, not an individual, that requires data storage as part of its operations, as opposed to an individual end user of such an application. Users access the system via an API, application program interface, that may access via an API key or blockchain account to access their program. dStor infrastructure providers provide equipment and internet connectivity to store data ingested into the system by users and rapidly deliver it on request. They're paid from the system revenue in relation to how much data they store and serve to users, meaning that they will have to compete with other storage node operators to some extent, as more performant systems will receive more requests and therefore earn more fees. This is an important part of the system. dStor itself is an organization that develops and advances the dStor technology, as well as marketing and selling the service to users. This role too may eventually be decentralized once the system's up and running. So dStor infrastructure. dStor outsources the operations of its computer infrastructure needs to those who have untapped capacity not currently being exploited. These providers offer computer storage with bandwidth in cooperation and competition with other providers to create a high capacity, high redundancy, high performance data storage and delivery distributed network around the world. and well below the cost of operating dedicated data centers. Although cloud computing has taken over the greatest share of today's business computing functions, many organizations do still need to operate their own computer infrastructure. Often this infrastructure is housed in co-location data centers that rent space, power, and connectivity to operate such equipment. Co-location data centers typically self-serviced in fixed size packages, and customers are often in the position of paying for services they don't fully utilize. dStor creates an opportunity for such operators to earn incremental income from their existing contracts and equipment. Co-location data centers themselves are actually excellent candidates for providing this service at extremely low costs. Many of these data centers were built before or in the early phases of the shift to cloud computing. They're typically over capacity and in search of revenue opportunities. In the space of a few empty racks and equipment, and personnel, and storage already there, these co-location data centers can easily provide many terabytes of storage and gigabytes per second of bandwidth. Another class of computer infrastructure providers are individuals who wish to defray the cost of fiber to the home service by adding network accessible storage device to their home network for the purpose of serving as a dStor storage outpost node. These can be scheduled to be out of service again during the hours of the week that the user is consuming high amounts of data, and then turn back on again while the operator is away from home and their service is otherwise idle. In this way, many people can defray the cost of their high-speed internet service. Finally, dStor offers an opportunity to earn revenue without owning any computer infrastructure. There are numerous providers online online computer services. Anyone can rent a server for a monthly fee, configured with ample hard drive and dedicated bandwidth to serve as a dStor outpost storage node. Many of these configurations are likely to be profitable for their operators. Crucially, none of these operations require much, if any, ongoing operations once initially set up via an easily executed dStor onboarding script. It's going to be easy. What will a dStor operator need? The basic setup is actually quite simple. For some, the only complicated part will be setting up an IPv6 connection instead of IPv4. Many of the parts of the world already have this as a standard, and it's only going to become more so now that the last of the IPv4 addresses have been assigned. But we decided to build dStor for this future, so we didn't have to upgrade soon. Aside from IPv6, a very simple computer with an Intel i3 or equivalent processor, 8 gigabytes of RAM is fine. This is the kind of computer that many people have sitting around unused. The minimum amount of storage space is 4 terabytes, and we recommend simply using standard fast 4 terabyte hard disk drives, not SSDs. The more drives a provider offers, the more money they can earn from storage fees. Where we are demanding is in the minimum amount of up bandwidth dedicated to dStor. There's a minimum of 50 megabytes per second. This keeps the system fast. As I've said before, cloud storage is really storage and delivery. In fact, the delivery is the more demanding of these. We will test outpost storage nodes regularly, and the better performing systems will ultimately get more data requests and earn more. I expect that many node operators will provide a gigabyte per second or more of dedicated up bandwidth to maximize their earning potential. Of course, infrastructure providers will also need a basic understanding of Linux operating systems to deploy dStor outpost storage node quick start scripts. But these scripts are going to be really easy, maybe even a single line of code. And we'll have tutorials. It will be easy. As a result, we expect that many users may just rent servers and online data centers, deploy the scripts, and collect monthly revenue. Some may pay for their fiber to the home and defray the cost, or even make a profit by attaching a storage node to their system for use while they're away from home. We plan to have an app to schedule such downtime and uptime. Running a dStor outpost storage node should be a money-making opportunity for many, many people around the world. So who are the users? The users of dStor will mostly be apps, developers, and businesses, especially at first. In time, individual users are likely to join. For example, many people have asked us about whether dStor can operate a website. It can. We've shown it many times in demos already. And for that matter, we've shown dStor operate streaming video at YouTube speeds. But the truth is, the vast majority of individuals will prefer using dStor through one of the interfaces being built by developers. Rather than managing their personal files directly through the dStor API or console interfaces, it'll be much more comfortable to use one of the many user-friendly dApps built on the dStor system. There are already projects underway to build a decentralized Dropbox-style app for document sharing and syncing, a decentralized video streaming platform, business data storage, and more. This is how most end users will interact. Of course, it's decentralized storage and people will be able to use it however they choose. But our initial market is developers. Developers will have the option of either REST or WebSocket connections to access the API layer for dStor. Developers will be able to create lifetime, time-based, and limited use tokens with specific access control lists that can be made into templates. Developers that need to issue their users dynamically generated API tokens will need to do so through the backend server, but users can directly store files to dStor once they have a token that allows such an action. As you can imagine, on top of creating dStor, designing pieces like the economic model and the documentation have been very large tasks for our team. Please believe that we are putting a giant effort into these and they will be released very soon. Just like the Telos launch, we believe there's a little value in just hitting an arbitrary date. We want to release information that's solid and dependable. That's our goal, and we will be soon sharing the economic model that works for both the users and the infrastructure providers. I truly wish that we could be doing that in this presentation, but it's coming quickly. What's the relationship between dStor and Telos? Well, unlike many previous attempts at decentralized storage, dStor is not really run on a blockchain at this time. It's an important complementary technology to blockchain, but it's not blockchain. dStor uses Telos to provide a way to empower payment and access permissions through smart contracts and login with Telos accounts. All of the internal workings of dStor will be held in TLOS tokens, not some additional token. But the payment interactions will be handled through various DeFi tools on Telos, and those coming soon from Transledger, like you might have just heard about from Dieter. This will allow payment through a variety of fiat and token currencies and allow infrastructure providers to withdraw their earnings however they choose. But under the hood, it's using the Telos token, and the traffic increases we can expect with all this additional value and liquidity will benefit Telos token holders, we hope. One of the hallmarks of decentralized storage, of course, is that you can't really stop people from using it as long as they pay. We can't really, and we shouldn't be making something that's only for Telos dApps alone. But during the early days, when our developer relations resources are quite limited, we intend to put Telos-based dApps always in front of the line. This will give Telos dApps probably a year's head start on the technology, and we think this will provide a massive leg up for Telos and Telos dApps. One question, just to touch on a point that we get a lot, a question we get a lot, dStor storage is not pay once and store eternally. There's no economic system that really works for that. Like other cloud storage, if you stop paying, the files get removed from the system. I don't think anyone expects any different, but I want to make that distinction. So where is dStor today? The dStor beta release will be in 3 phases. Phase 1 will see us working with a small number of developers and storage node operators who we're already in contact with. This starts up the mesh and lets us test the API with developers outside our own company, but still those who we have close working relationships with. A lot of these will be people who are involved in Telos as block producers and developers and TCD members already. Software can be tricky, and we want to make sure that any inevitable mistakes that happen within this are kept within our close circle at first. We still expect beta 1 to start in January and last about 2 months. Beta 2 will see a wider expansion of the mesh and developers. By March, we hope to have an updated version of the API and new apps that are ready for developers outside our immediate circle. We hope to see steady growth and improvement through about 2 months of this stage. Documentation should also improve markedly as we bring in templates and starter scripts and tutorials. Beta 3 will be an extended period. dStor will essentially be open for business, but still in beta, so we can set proper expectations for users and continue to improve the service. We think that this is probably could be up to a year long, or the entire beta system can be a year long. Again, we'll release this when it is ready, and it's very close to being ready. And those documents will be coming out pretty much all at once. All right, we're really excited to be able to share more about pricing, economics, and documentation very soon as we enter the dStor beta phase 1. I want to express how grateful I am to our initial partners who are helping us to build the initial dStor public cloud and test our developer tools. These are invaluable partners to us and invaluable to the future success of dStor. We're very eager to bring more people into the system soon. We were hearing from people. We're excited to work with you. Let us get the system really strong for everyone soon. Thanks so much for listening. I'm here for questions if we have them. I'm just really excited about this whole system.
Thank you, Douglas. That was an excellent presentation. That's in a short notice. Thank you so much for covering, Stephanie.
Thank you very much, Michael.
So the way I understand it, so all we need is to join IPv6. To join the dStor, we need to set up IPv6 plus the hard disk drive, right? About 4 terabytes, and no need for SSDs. Is there a reason for that? SSDs are fast, right?
No, yeah, SSDs, because SSDs are very fast, but SSDs are expensive. And this is like, we should think about this like a sort of a new form of mining that doesn't have the same intense high startup cost as cryptocurrency proof of work mining, very low, and also doesn't have the rapid ramp down in earnings we shouldn't have. But still, especially in the beginning, people need to be cost competitive, right? And hard disk drive, fast hard disk drives are fast enough. So the extra cost of SSDs is not necessary. I would advise people to maximize their earning by getting a lot of storage, a lot of dedicated up bandwidth. That actually in our current model gets rewarded 3-to-1 over storage itself. But storage is also important, and people who have large amounts of there are people out there who we know have large amounts of storage, and they can use it, right away as soon as this comes out and start making money from that rather than have it sit idle.
So there is so if someone has this storage at maybe their office, they can probably join dStor, right? Now, is there some mechanism to check that these computers are online, and that's how they get paid, or what's the mechanism for payment?
Yeah, so the mechanism for payment is the income that dStor makes from storage and delivery of files is pooled, and it's shared to storage nodes pro rata in relation to how much storage, pinned storage they provide, and those are the files. That means the files that we have asked them. The dStor system has assigned them when a file got uploaded to be stored on that node. This happens randomly across the nodes, and it's between 15 and 20 copies, depending on how many nodes ultimately there are. So if the system has asked you to store that and you have that, then you'll be paid pro rata the 1/4 part of this that goes to storage. If a node goes offline and loses its seed, a new seed will be assigned, and then that will be paid for that seed. The other chunk, the other 3/4 of the pay, is going to is based on a pro rata sharing of the bandwidth. If you're running a storage node, you will get a payment for that's roughly a quarter of the total income. That's based on the amount of pinned storage that you're providing for nodes, and then about 3/4 is going to the amount of actual data that you are able to serve. Then there's small escalators for high performance systems that further drive that as bonuses, basically, that further drive the advance of the system for like elite nodes that are really delivering a lot of value. But that's the basic way that people get paid.
Now, the other question that comes to mind is encryption, because some of the data that we want to store, we may not want that to be visible to public, right? So we are encrypting on our side, or is it encrypted on the dStor side?
Initially, that will be encrypted on by the user. So dStor doesn't initially offer encryption. However, we will soon be offering. There will still be tools for encrypting on the upload, is our expectation. But initially it's storage. So whether you want to store clear text files or encrypted files or sharded files or some combination thereof, that is the DApp will upload those.
So I can see a lot of use cases for this, right? There's going to be, I anticipate, a huge demand, and maybe it is going to be one of the flagship products for Telos. So we need a very nice UI for this. And is it almost ready, right, Douglas?
So I want to be clear. GoodBlock and dStor, the company that will become dStor, we're building the platform. And we are looking to DApp developers to build the apps on top of it. I think we really want to concentrate on making it a fantastic platform. There's a lot of great DApp developers with a lot of ideas about how to use this. And we are already in contact with them. There are people already building these. But as I said before, probably the way most people will interact will be with a DApp that is doing, their file storage for them, or their video streaming for them, right? We will work with those companies, but we're not actually looking to build all those DApps. It's important that we focus, we need to focus our efforts on making the platform fantastic for everyone, right? The DApps are coming because this is new. It's available. It's, like I said, it's been a choke point, a logjam in DApp development, and we think that especially from the initial response, we haven't done anything really except put out a couple of videos. We've been in very stealth mode, and already people are very excited, to start using this. So we aren't concerned about whether there will be DApps that are developed on it. But yes, once we release this, people shouldn't expect that they can instantly do a lot of stuff on dStor. It's a release to developers to start building those and testing out those DApps.
Excellent. Well, thank you so much, Douglas. It's a pleasure to have you always.
Thank you very much, Michael. Thanks, everybody.